June 10th, 1944. Omaha Beach, Normandy. Dawn. Lieutenant Colonel Andrew T. McNamara stands knee-deep in seawater, watching his men drown. Not in the surf, not from German bullets. They're drowning in success. The beach is won, but it's chaos. Thousands of tons of supplies pile up on the sand. Ammunition crates, fuel drums, ration boxes, medical supplies, forming mountains of material that grow taller by the hour. Ships offshore keep unloading. More supplies, more equipment. The invasion force is pushing inland, screaming for bullets and gasoline. But everything they need is right here, stuck, useless, buried under more cargo that keeps arriving. McNamara, the Army's transportation chief for this sector, does the math in his head. It's simple, brutal arithmetic. His units are advancing 15, maybe 20 miles a day. Each mile takes them farther from these supplies. Each mile stretches the supply line thinner. And the trucks. God, the trucks. Half of them are already broken down. He watches another deuce and a half lurch past, black smoke pouring from its exhaust, making a sound like a dying animal. The driver nurses it forward in first gear. Behind it, 3 more trucks sit silent, hoods open, mechanics working desperately in the sand. Someone hands McNamara a report. He reads it twice, hoping he's misunderstood. The Allied advance is about to outrun its own supply line. In 2 weeks, maybe 3, the entire offensive could grind to a halt. Not because of German resistance, because of a problem nobody saw coming. They're running out of trucks that actually work. And the ones they have, they're the wrong design entirely. What McNamara doesn't know, what nobody knows yet, is that the solution to this crisis is already sitting in motor pools across France. Thousands of trucks that Army procurement officers wrote off as obsolete, worthless, built on a design so unconventional that military planners fought for years to keep it out of the war. These trucks were created by one man, a mechanic from Wisconsin who never finished high school, who spent 20 years being told his ideas were impossible. His name was William S. Knudsen, and his worthless trucks were about to save the Allied invasion. Our story begins 30 years before D-Day. 1914, Detroit, Michigan. William S. Knudsen, Big Bill to everyone who knows him, is 35 years old and he's rebuilding his life. Again. He's 6'3", Danish-born, with hands like machinery and a mind that never stops working. He came to America at 20, with $8 in his pocket and a third-grade education. Taught himself English by reading newspapers. Taught himself engineering by taking apart machines and putting them back together better than he found them. Now he's working for a new company called Ford Motor Company, and he's watching Henry Ford make the same mistake over and over. The Model T is revolutionary. Everyone agrees on that. But Ford's manufacturing process is chaos. Knudsen watches parts pile up at one end of the factory, while assembly lines sit idle at the other. He sees workers walking hundreds of unnecessary steps every day. He sees efficiency bleeding away in 1,000 small wounds. He can't help himself. He starts redesigning things. First, just his own workstation. Then his section of the line. Then entire manufacturing processes. He doesn't ask permission. He just does it, proves it works, then shows Ford what he's done. Ford hates it. Not the results. The results are undeniable. Production is up. Costs are down. But Ford hates that Knudsen did it without asking. Hates that this immigrant mechanic thinks he knows better than Henry Ford. In 1921, Ford fires him. Knudsen lands at General Motors. And this time, he has an idea that won't let him go. He's been thinking about trucks. Military trucks specifically. He served as a production consultant during World War I, saw how army trucks failed in the field. They were essentially cars with bigger beds. Same basic design philosophy. A separate frame, a heavy chassis. Everything built for durability over flexibility. But Knudsen keeps thinking, what if we did it differently? What if, instead of building a truck to be indestructible, we built one to be fixable? Here's what Knudsen proposes to GM's board in 1923. A truck with interchangeable parts. Not just within the same model, between different models. Different years. Different configurations. A truck where the cab, the bed, the engine, the axles, everything uses standardized mounting points. So you could pull parts from a 1925 model and bolt them onto a 1928 model, and they just work. A truck built on what he calls a building block philosophy. The board looks at him like he suggested they make trucks out of paper. This isn't how vehicles are built. Each year's model is supposed to be new, improved, different. That's how you sell upgrades. And this standardization thing, it means committing to a design for years, maybe decades. It means giving up flexibility to change and improve. One board member asks the obvious question, why would the army even want this? Knudsen's answer is simple. Because wars don't stop for parts, he explains. In World War I, the army had dozens of different truck models from different manufacturers. Each one needed its own specific parts. When something broke in the field, and things always broke, you needed the exact right part from the exact right truck. Most of the time you didn't have it. So the truck sat there, useless, while some other truck was being cannibalized for parts. His idea solves that. Any truck becomes a parts donor for any other truck. Your supply chain gets simpler. Your repair times get faster. You get more operational vehicles with fewer total parts. It's brilliant. It's also terrifying to manufacture. The precision required to make parts truly interchangeable across years of production. The quality control, the documentation, the commitment. Nobody's ever done it at this scale. GM says no. Knudsen keeps pushing. He builds prototypes using his own budget. He brings in army mechanics to test them. He documents everything. Repair times, parts usage, failure rates. Finally, in 1931, GM agrees to let him try. They'll build a new line of trucks, the CCKW series, using Knudsen's building block philosophy. But it's a test, a small production run. The trucks start rolling out in 1932, and the US Army immediately hates them. Here's what Army procurement officers see when they evaluate Knudsen's trucks. They're weird. The cab is boxy and utilitarian. None of the curved, stylish lines of contemporary vehicles. The engine access is unconventional. The whole design screams compromise and minimum acceptable standards. But the real problem is philosophical. The Army's vehicle procurement doctrine in the 1930s is built around durability. They want trucks that won't break. Knudsen is selling them trucks that are easy to fix when they do break. To the procurement officers, this feels like admitting defeat before you start. One internal Army memo from 1933 calls Knudsen's design a mechanic's solution to an engineering problem. It's not meant as a compliment. There's also a practical concern. The Army's existing supply system is built around the current truck designs. Switching to Knudsen's standardized system means retraining mechanics, reorganizing parts depots, rewriting maintenance manuals. It's a massive headache, so they shelf it. The army places small orders, enough to keep GM interested, but makes it clear these trucks are for secondary duties only, not frontline service. Knudsen, now a GM executive, watches his trucks get sidelined. But he doesn't stop developing them. Every year, he refines the design, makes the parts' interchangeability even better, improves the documentation, builds up a library of modifications that can be swapped in and out, like Lego blocks. By 1939, when Germany invades Poland, Knudsen has spent 17 years perfecting a truck design that his main customer doesn't want. Then, everything changes. December 1940. William Knudsen gets a phone call from President Franklin Roosevelt. The president doesn't waste time on pleasantries. He needs Knudsen in Washington. Immediately. The United States isn't in the war yet, but it's coming, and America is catastrophically unprepared. The military needs to scale up production of everything: planes, tanks, ships, weapons, and they need someone who actually knows how to manufacture things at scale. Roosevelt wants Knudsen to run it. Knudsen says yes. He resigns from GM, takes $1 a year salary, and moves to Washington to head the Office of Production Management. Now, here's where it gets interesting. Knudsen is suddenly in charge of all military production, including vehicles. And he's got a truck design sitting in his back pocket that he knows is better than what the army is currently using. But he can't just order the army to use it. That would be a conflict of interest, maybe even corruption. He's the former GM executive advocating for a GM product. So he does something clever. He quietly starts routing Knudsen design trucks to training units, to National Guard divisions, to secondary theatres, places where they'll actually get used but where nobody's paying close attention. And he waits for reports to come back. The reports start arriving in mid-1941. From training bases across the country, maintenance officers are noticing something odd. These weird GM trucks, the boxy ones with the unconventional design, they're staying operational longer than anything else in the motor pool. Not because they don't break down. They break down at normal rates. But when they break, they get fixed fast. A mechanic at Fort Benning writes a report that catches someone's attention. He describes pulling a transmission from a 1937 truck and installing it in a 1941 truck. Same-day repair. The parts just fit. Another report from Fort Hood. We cannibalized 3 trucks for parts and kept 12 operational. With standard vehicles, that ratio would be closer to 1-for-1. The evidence is accumulating. In training environments, where you're running vehicles hard and parts availability is inconsistent, Knudsen's design is outperforming everything else. But the Army's procurement office still isn't convinced. These are training situations, they argue, not combat conditions. Then, December 7th, 1941, changes everything. Pearl Harbor gets hit, America is in the war, and suddenly the Army needs trucks. Lots of them. Immediately. They don't have time to be picky anymore. In early 1942, the Army places massive orders for vehicles. All manufacturers, all models, including, almost as an afterthought, a big order for Knudsen's CCKW series. The trucks start shipping to Europe and the Pacific, thousands of them. And for the first time, they're going into actual combat theatres. Knudsen watches the production numbers climb. But he's got a gnawing worry in his gut. His trucks are about to face their real test. And if they fail, if his 17-year obsession turns out to be wrong, A lot of soldiers are going to pay the price. May 1943, Tunisia, Sergeant James Jimmy Wheeler is having the worst day of his career as a motor pool mechanic. His unit, a trucking company attached to Patton's 2nd Corps, has been moving supplies up to the front lines for 6 weeks straight. North Africa is a vehicle killer. The heat, the sand, the distances, everything is designed to break trucks. And Wheeler's trucks are breaking. Out of his company's 40 trucks, only 19 are operational. The rest are scattered across Tunisia, broken down, waiting for parts that may never come. The worst part? Wheeler knows he could fix most of them. The problems aren't complicated. Busted fuel pumps, worn clutches, cracked radiators. But each truck is a different model from a different manufacturer, and each one needs its own specific parts. He's got a pile of parts. Wrong parts, they don't fit anything he's got. Then a new convoy arrives from the depot. Wheeler watches them unload, and his heart sinks. More trucks, different models, more parts, headaches. Except, he looks closer. These trucks are all identical. Boxy cabs, ugly as sin, all wearing the same designation, GMC CCKW 353. A lieutenant tells him these are his new trucks. The old ones are being written off. Wheeler spends that evening walking around the new trucks with a wrench and a notepad, documenting what he's seeing. And slowly something starts to click in his head. These trucks, they're all the same, not just similar, identical in ways that matter. He pulls a fuel pump from one truck, walks over to another truck, bolts it in, perfect fit. He tries it again with different parts. Air filter, alternator, drive shaft. Every time, perfect fit. Over the next 3 months, as his unit pushes across North Africa, Wheeler becomes the evangelist for these weird GM trucks. He starts keeping the most damaged ones as parts trucks, rolling warehouses of components. When a truck breaks down, his men strip what they need from the parts trucks and get the operational vehicle back on the road in hours instead of days. His company's operational rate climbs to 85%, best in the division. Word spreads. By late 1943, reports are flooding into the War Department from every theatre. North Africa, Italy, the Pacific, Britain. The message is consistent. Knudson's trucks, now officially designated the GMC CCKW, but universally called Jimmy, or Deuce and a half, are outperforming every other vehicle in the supply chain. Not because they're more powerful, not because they're faster or more durable, because when they break, they get fixed. An analysis from the Motor Transport Service in Italy shows the stark numbers. Standard army trucks average 3.7 days from breakdown to operational CCKW trucks. Average 0.8 days from breakdown to operational. That difference is everything. In modern warfare, supply is life. An army advances on its logistics as much as its courage. Every day a truck sits broken is a day soldiers at the front don't get ammunition, food, fuel. The army starts placing bigger orders for CCKWs, but production is already maxed out. GM can only build them so fast. Then someone in the War Department has an idea. What if we sent more CCKWs to the units that need them most? The long-haul supply companies. The ones running the most miles, under the worst conditions. The ones that are about to face the biggest logistical challenge of the war. The Normandy invasion is being planned, and someone needs to figure out how to keep an entire invasion force supplied as it drives across France. That someone is Lieutenant Colonel Andrew T. McNamara, and he's about to need every single one of Knudson's weird trucks he can get. January 1944, London. McNamara sits in a planning room with maps covering every wall. The maps show France, the roads, the distances. The math is brutal. The invasion plan calls for landing multiple divisions on the Normandy beaches, then advancing inland as fast as possible. The goal is to break out of the coastal areas and drive toward Paris, then Germany. But here's the problem. The distance keeps growing. On D-Day, the supply line will be a few miles long. Easy. 1 week later, maybe 15 miles. 2 weeks, 30 miles. 1 month, could be 100 miles or more. Every mile adds complexity. Trucks have to drive farther to deliver supplies. That means more fuel consumed, more wear on vehicles, more breakdowns, more parts needed. McNamara runs the numbers over and over, trying to make them work. A typical army truck company has 48 trucks. In normal operations, you expect about 70% operational readiness. That's 33 trucks actually hauling supplies. The rest are down for maintenance or repairs. If the supply line stretches to 100 miles, each truck needs to drive 200 miles. Round trip to make a delivery. At an average speed of 25 miles per hour on war-damaged roads, that's 8 hours of driving. Add loading and unloading time, and you're looking at 10 to 12 hours per cycle, which means each truck makes maybe 1 run per day. 33 trucks, 1 run each carrying an average of 5 tons of supplies. That's 165 tons per day per company. The invasion force will need thousands of tons per day. McNamara keeps dividing, multiplying, calculating. The numbers don't work. Unless he looks at the vehicle allocation lists. Most trucking companies have mixed fleets. Different models from different manufacturers, because that's all that was available when the companies formed. But some companies, the newer ones, have been issued primarily CCKWs. He pulls the operational readiness reports for those companies. 90%. Some even higher. McNamara does the math again, using 90% operational readiness instead of 70. The numbers get better. Not good, but better. He makes a decision. Every trucking company being assigned to the supply run will be re-equipped with CCKWs, all of them. No mixed fleets. And they're going to need hundreds of these companies. August 25th, 1944. The breakout has happened. Allied forces have punched through the German lines in Normandy and are racing across France. Patton's Third Army is advancing 50 miles a day. It's glorious. It's ahead of schedule. It's also a logistics nightmare. McNamara's supply line now stretches over 300 miles from the beaches to the front lines. His truck companies are running 24 hours a day, and it's still not enough. The forward units are literally running out of gas. Patton's tanks are stopping not because of German resistance, but because their fuel tanks are empty. Something has to change. On August 25th, McNamara implements a plan that's been in development for weeks. They're calling it the Red Ball Express. The concept is simple but radical. Dedicated supply routes with absolute priority. Trucks running in convoys, non-stop, around the clock. No civilian traffic allowed. No military traffic unless it's part of the Red Ball. Every resource, members of parliament, maintenance crews, fuel depots, organised solely around keeping these trucks moving. The routes are marked with red balls painted on signs, hence the name, and every truck in the Red Ball Express is a GMC CCKW. Every single one. This is what Knutson's design was built for. Hundreds of trucks driving thousands of miles in the worst possible conditions, breaking down constantly, being repaired by exhausted mechanics in the field, parts being scavenged from damaged vehicles to keep other vehicles running. The interchangeable parts philosophy is about to face its ultimate test. The men running the Red Ball Express are predominantly African American. This isn't an accident. The Army in 1944 is still segregated, and black soldiers are largely assigned to service and supply units rather than combat roles. The injustice of this is obvious and shameful, but it has an unintended consequence. The Red Ball ends up being manned by some of the most motivated, skilled, and determined men in the Army. They know they're proving something every day. Private First Class. Willie Mitchell is a driver with the 3266 Quartermaster Service Company. He's 23 years old from Georgia, and before the war, he worked as a mechanic in his uncle's garage. Mitchell loves his truck. It's not pretty. The cab is cramped, the suspension is brutal, and after a 12-hour run, his entire body aches. But the truck works. Every time, when something breaks, and something is always breaking, he or his company's mechanics can fix it fast. He describes it in a letter home. This truck is like a mule. Ugly, stubborn, but it'll work itself to death if you ask it to. The Red Ball runs 20 hours a day. Drivers work in teams, swapping behind the wheel to keep moving. They drive through the night with blackout lights, tiny slits of illumination that barely show the road. They drive through German stragglers and occasional sniper fire. They drive on roads cratered by artillery and bridges that are barely standing. And their trucks keep running. Mitchell's maintenance log from September 1944 shows the story. September 3rd, replaced fuel pump. Parts truck number 37. September 7th, replaced drive shaft. Parts truck number 42. September 11, replaced radiator. Parts truck number 37. September 15th, replaced transmission. Parts truck number 51. September 22nd, replaced alternator. Parts truck number Nesta 42. 5 major repairs in 3 weeks, each one completed in less than a day, each one using parts pulled from damaged trucks and bolted straight into his vehicle. Without Knutson's interchangeable design, Mitchell's truck would have been deadlined, stuck waiting for parts, at least 3 times. Instead, it kept rolling. Multiply Mitchell's story by thousands of drivers, and you start to understand the impact. Here's something nobody planned for: the parts truck economy. By October 1944, every Red Ball company has developed the same system. They keep a few trucks, usually the most damaged ones, as dedicated parts donors. These trucks never get fully repaired. They're deliberately kept broken, but they're kept organized. Sergeant Robert Hayes, a maintenance supervisor with the 514th Quartermaster Company, runs his parts trucks like a library. He keeps inventory lists. He knows exactly what's available on each truck. When a driver reports a problem, Hayes can tell him immediately which parts truck to hit for the needed component. The system works because every truck is identical. A fuel pump from a parts truck fits any operational truck. An axle from one truck bolts right into another truck. Even complex components like transmissions and engines can be swapped with basic tools. Compare this to mixed fleet companies still operating standard Army trucks. When something breaks, they have to request parts through official channels. The request goes to a depot. The depot checks inventory. If they have the right part for that specific truck model, they ship it. This process takes days, sometimes weeks. Red Ball companies don't wait. They fix it themselves immediately, using their parts trucks. The operational readiness rates tell the story. Mixed fleet companies, 68% average operational rate. CCKW only companies, 91% average operational rate. That 23 percentage point difference is the margin between success and failure for the entire supply operation. November 1944. The Red Ball Express has been running for 3 months. It's moved over 400,000 tons of supplies to the front lines. It's one of the great logistical achievements in military history. It's also falling apart. The trucks are exhausted. These vehicles were designed for maybe 30,000 miles of lifetime use. Many Red Ball trucks have already exceeded that. They're held together by determination and scavenged parts. McNamara faces a critical decision. The front has stabilized as winter sets in. The Allied advance has slowed. They don't need the Red Ball running at full intensity anymore. He could shut it down. Give the trucks time to recover, get properly maintained, rebuilt. But intelligence reports suggest the Germans are planning a winter offensive. If that happens, they'll need every truck operational immediately. McNamara makes a gamble. He orders a 2-week maintenance stand down. The Red Ball will stop running. Every truck will go through complete inspection and repair. Engines rebuilt. Transmissions replaced. Everything brought back to operational standard. And here's where Knudsen's design philosophy pays off one more time. The maintenance crews don't need to wait for new parts. They have the parts trucks, dozens of them per company. They start a systematic rebuild, pulling every good component from the parts trucks and using them to repair the operational vehicles. It's like a massive organ transplant operation, but with trucks. Engines come out of parts trucks and go into operational trucks. Transmissions, axles, electrical systems. Everything gets swapped, tested, reinstalled. The mechanics can work fast because they know every truck is the same. No guessing about compatibility. No waiting to verify parts numbers. If it bolts into one CCKW, it bolts into all of them. By the end of the 2 weeks, McNamara's companies have rebuilt hundreds of trucks, using nothing but their existing inventory of parts vehicles. The Red Ball is ready to roll again. December 16th, 1944. The Germans launch their surprise offensive through the Ardennes forest. The Battle of the Bulge begins. Everything McNamara worried about comes true. Allied forces are suddenly fighting on multiple fronts, in winter conditions, burning through supplies at an unprecedented rate. The careful logistics planning goes out the window. The Red Ball Express goes back to full operation. 24 hours a day. No maintenance breaks, no rest. Willie Mitchell and his truck are back on the road, running supplies to besieged units. He's driving through snow now, on ice-covered roads, with German artillery falling close enough that he can feel the concussions. His truck breaks down on December 22nd. Transmission failure. 6 months ago, this would have sidelined him for days or weeks. But his company's maintenance section has a replacement transmission. Pulled from a parts truck 2 weeks ago during the maintenance stand down. Already cleaned and ready. They swap it in 4 hours. Mitchell is back on the road before midnight. This scene repeats thousands of times across the Ardennes. Trucks break, mechanics fix them. Fast, the supply line holds. Later analysis will show that during the Battle of the Bulge, Red Ball companies maintained an 87% operational rate despite extreme conditions and mechanical stress that should have broken them. The reason why is sitting in motor pools across France. Knudsen's ugly, unconventional trucks that refuse to quit. May 1945. Germany surrenders. The war in Europe ends. The Red Ball Express has moved over 412,000 tons of supplies across more than 400 million miles of driving. It's kept an entire invasion force supplied for 9 months of continuous combat, and it did it primarily with one truck design. William Knudsen, now back in Detroit, receives a letter from General Dwight Eisenhower. The Supreme Allied Commander wants to thank him personally for the trucks. Eisenhower writes, "Without the CCKW, the advance across France would have been impossible. The design philosophy you championed saved the campaign. It's vindication." After 17 years of fighting for an unconventional idea, Knudsen was right. But here's the thing. He almost wasn't. If the army had stuck with standard procurement policies, the Red Ball would have been running mixed fleets. The operational rates would have been lower. The supply line would have struggled, maybe broken. The Allied advance might have stalled. History might have turned on something as mundane as interchangeable truck parts. In the years after World War II, Knudsen's design philosophy becomes industry standard, not just for military vehicles, for everything. Cars, machinery, appliances. The idea that parts should be standardized and interchangeable across models and years becomes the foundation of modern manufacturing. But Knudsen doesn't see much of it. He dies in 1948, at age 69, of a cerebral hemorrhage. He's remembered primarily for his role in wartime production, not for his innovations in vehicle design. The CCKW trucks serve for decades after the war. They're used in Korea, Vietnam, civilian applications worldwide. Some are still running today, 80 years after they rolled off the assembly line. Willie Mitchell returns to Georgia after the war. He opens his own garage, specializing in truck repair. When asked about his time in the Red Ball, he always mentions his truck. "That ugly thing saved my life probably a dozen times," he says in a 1982 interview. Not because it didn't break, it broke all the time, but because when it broke, we could fix it. The Red Ball Express is remembered as a triumph of logistics and determination. The men who drove it, predominantly black soldiers proving their worth in a segregated army, finally get recognition for their crucial role. But the trucks themselves, the ugly workhorses that made it all possible, fade into footnote status. Here's what strikes me about this story. The Red Ball Express succeeded because someone thought about failure differently. Every other truck manufacturer was trying to build vehicles that wouldn't break down. Knudsen built vehicles that would definitely break down, but could be fixed quickly when they did. It's a fundamentally different philosophy. Instead of trying to prevent failure, you accept it as inevitable and designed for recovery. That mindset, planning for repair rather than hoping for perfection, saved the Allied supply line in World War II. It kept hundreds of thousands of soldiers fed, fueled, and armed during the most critical campaign in modern history. And it started with a mechanic from Wisconsin who got fired from Ford, spent 17 years being told his ideas were worthless, and never stopped believing he was right. The next time you see an old military truck at a museum or a veterans parade, one of those boxy, ugly Deuce and a half trucks, remember what it represents. It's not just a vehicle, it's a philosophy, a solution to a problem that most people didn't even realize existed, and a reminder that sometimes the most important innovations come from people who refuse to accept that's just how things are done. And for our bonus finale, here's a fan favorite you won't want to miss. The fluorescent lights hum in the basement laboratory of the Reichsluftfahrtministerium in Berlin. It's March 14th, 1943, and Oberleutnant Heinrich Müller runs his fingers across the olive-drab metal casing of an American SCR 300 radio set. The device sits on the examination table like a patient in surgery, its guts exposed, wires trailing across the white surface like entrails. Müller's hands are shaking. He's been a signals intelligence officer for the Luftwaffe for 3 years. He's examined British radios, Soviet equipment, even experimental French designs salvaged from warehouse fires. But this is different. Wiederholen Sie das? He says quietly to his assistant. Repeat that. The young technician, Werner Schmidt, adjusts his glasses and checks his notes again. The effective range, Herr Oberleutnant. In field conditions, with a portable unit, 35 kilometers, perhaps more, 35 kilometers, more than 20 miles, for a radio that a single soldier can carry on his back. Müller looks at the neat assembly before him. The American craftsmanship is unlike anything he's seen. Not elegant, not beautiful in the German engineering sense, but practical, efficient, reliable. The frequency modulation system eliminates the static that plagues every German field radio. The batteries last 3 times longer than expected. And the range, he thinks about German infantry units, still using radios that barely function beyond 5 kilometers. He thinks about the complex relay systems they need, the communication breakdowns, the orders that never arrive. How many of these do they have? Schmidt asks. Müller doesn't answer. He's staring at the production stamp on the radio's chassis. Galvin Manufacturing Corporation, Chicago, Illinois. Serial number 4721. 4721. This is the 4721st unit, built by a single company in a single factory. And it's March 1943. America has been in the war for barely 15 months. Mein Gott, Müller whispers. What have we done? Before we can understand what the Germans discovered, we need to go back to 1940, when the nature of modern warfare was being rewritten in real time. The German blitzkrieg that swept across Europe wasn't just about tanks and aircraft. It was about communication. While French and British units struggled with bulky, unreliable radios that often failed at crucial moments, German panzer divisions moved with unprecedented coordination. Tank commanders talked to each other. Ground units called in air support. Artillery adjusted fire based on real-time reports from forward observers. The Germans had invested heavily in radio technology throughout the 1930s. Their Tornfu series of radios, particularly the Tornfu 2, gave them a critical edge in the early war years. But these systems had significant limitations. They were heavy, required multiple operators, and had limited range. Most critically, they used amplitude modulation, or AM, which was susceptible to interference from everything. Enemy jamming, atmospheric conditions, even their own vehicle engines. The British faced similar challenges. Their wireless set number, 18, introduced in 1940, was an improvement over previous designs, but it still weighed over 20 pounds and required careful tuning by trained operators. In the chaos of combat, that careful tuning was often impossible. And then there was the fundamental problem of tactical communication. In infantry combat, you needed to talk to soldiers who might be scattered across miles of terrain. You needed something portable, something reliable, something that worked when bullets were flying and everything was falling apart. In 1940, nobody had solved this problem. The technology simply didn't exist. Across the Atlantic, in Chicago laboratory, a man named Donald L. Hings was about to change that. The story of the SCR 300 actually begins in Canada in 1937. Donald Hings, a Canadian engineer working for CM&S, created what he called a pack-set radio system for prospectors working in remote areas. It was revolutionary, a truly portable two-way radio that one person could carry and operate. But when World War II began, the technology caught the attention of the US Army Signal Corps. They had a problem. American military doctrine emphasized mobility and combined arms coordination. Infantry, armor, artillery, and air support all needed to work together seamlessly. The existing radio systems weren't cutting it. In 1940, the Signal Corps approached Galvin Manufacturing Corporation, a Chicago company that had made its name building car radios. The company's founder, Paul Galvin, had recently rebranded his consumer products under a catchy new name, Motorola. The Army's requirements were specific and demanding. They needed a portable radio that could be carried and operated by a single soldier, work reliably in any weather conditions, maintain clear communication over substantial distances, be simple enough that any infantryman could use it with minimal training, be mass-produced in huge quantities. It was a tall order. But Motorola engineer Henryk Magnuski thought he could do it. Magnuski was a Polish immigrant who'd fled Europe just before the war. He understood radio theory at a deep level, but he also understood American industrial methods. He knew that whatever they designed had to be manufacturable on an assembly line, with standardized parts that could be produced by workers with minimal specialized training. The breakthrough was frequency modulation, or FM. FM transmission was far more resistant to interference than AM. It produced clearer audio and was less susceptible to noise. Edwin Armstrong had pioneered FM technology in the 1930s, but it had been largely confined to experimental broadcasts. Magnuski realized it was perfect for tactical military communications. By early 1941, Motorola had produced the first prototype of what the Army designated the SCR 300. SCR stood for Signal Corps Radio. The 300 was just a sequential designation number, but it would become one of the most important three-digit numbers in military history. The SCR 300 was remarkable. It weighed just 35 pounds, including batteries. It could maintain clear voice communication over ranges exceeding 20 miles in ideal conditions, and reliably over 10 to 15 miles in typical field conditions. It operated on FM frequencies between 40 and 48 megahertz. It had 18 preset channels, so operators could quickly switch frequencies without complex tuning. But the most remarkable thing about the SCR 300 was how simple it was to use. You turned it on. You selected a channel. You pressed the push-to-talk button on the handset. You talked. That was it. A private, fresh out of basic training, could be operating one effectively within an hour. The Army loved it. In December 1941, when America entered the war, Motorola received orders to begin mass production immediately. By mid-1942, SCR 300 units were rolling off assembly lines at an astonishing rate. Motorola's factories in Chicago were running multiple shifts. They were training workers, many of them women, as men enlisted or were drafted, to assemble the units with assembly line precision. Quality control was rigorous. Every unit was tested before shipping. The first SCR 300s reached American forces in North Africa in late 1942. Within weeks, they were changing how American infantry units fought. A platoon leader could now coordinate his squads in real time. A forward observer could call in artillery fire and adjust it second by second. A company commander could talk directly to battalion headquarters without needing a vehicle-mounted radio or a complex relay system. The Germans had nothing comparable. Nothing even close. The first documented capture of an SCR 300 by German forces occurs on February 19, 1943, near the Kasserine Pass in Tunisia. Oberst Wilhelm Müller, no relation to our Heinrich Müller in Berlin, commands a battalion of Panzer Grenadiers in the 10th Panzer Division. His units have been pushing American forces back for 3 days. The Americans are green, inexperienced, still learning the harsh lessons of desert warfare. The Germans have been doing this since 1941, but something is different about these Americans. Something Müller can't quite identify. Artillery fire adjusts to hit his advancing troops with uncanny accuracy. American air support appears exactly where it's needed, exactly when it's needed. On the third day, Müller's men overrun an American position near a dried riverbed. Among the captured equipment, a sergeant brings him something unusual, a large radio set in an olive-drab backpack frame. "Was ist das?" Müller asks his signals officer, Hauptmann Dieter Franz. Franz examines it. It's unlike any radio he's seen. The construction is strange. Modular components, easy to access. There's a handset attached by a coiled cable. The controls are labelled in English, but they're simple, almost childishly simple. Channel selector, volume, power. Franz, who speaks some English, reads the label. Radio set SCR 300A. "Can we make it work?" Müller asks. Franz tries. He finds the battery compartment. The batteries are still good. He powers it on. There's a hum, then voices. Clear voices, speaking English, no static, no crackling. American voices, coordinating positions, calling in fire support. Franz's eyes go wide. Herr Oberst, this range, this clarity. Müller takes the handset. He listens to the American radio traffic. They're not even bothering with complex codes. The communications are too fast-paced, too immediate. He hears a lieutenant calling to his company commander. He hears someone requesting ammunition resupply. He hears someone else coordinating with artillery. And it's all crystal clear, as if they were standing next to him. "How far away are these units?" Müller asks. Franz consults his map and triangulates based on the positions being discussed. 15 kilometers, Herr Oberst. Perhaps more. 15 kilometers. 10 miles, with a backpack radio, with perfect clarity. Müller feels a cold certainty settle in his stomach. Get this to signals intelligence immediately. They need to see this. The SCR 300 arrives in Berlin 3 weeks later. It's assigned to Oberleutnant Heinrich Müller at the Luftwaffe's Signals Research Facility. Müller has examined captured enemy equipment before, but he approaches this device with particular interest. The field reports from Tunisia have been disturbing. The Americans seem to have solved the tactical communications problem that has plagued every army in this war. Müller begins his examination. on March 14th, 1943. Heinrich Müller is methodical. He photographs the SCR 300 from every angle before disassembling anything. He catalogues each component. He measures weights and dimensions. He tests the battery voltage and capacity. Only then does he begin the careful process of taking it apart. His assistant, Werner Schmidt, takes notes in meticulous Gothic script. Every observation is recorded, every measurement documented. The first surprise is the construction quality. German military equipment is built to exacting standards, precision machined parts, robust assemblies, carefully calibrated components. This American radio is different. The parts are standardized, interchangeable. The assembly is clever but not complicated. It's clearly designed for mass production. This is industrial design, Müller observes to Schmidt, not precision engineering. They've optimized for manufacturing speed, but as Müller digs deeper, his respect grows. The frequency modulation system is elegant. The channel selection mechanism is simple but effective. The power regulation is efficient. The Americans haven't just built a working portable radio, they've built one that balances performance, reliability, simplicity, and manufacturability. Over the next week, Müller conducts extensive tests. He measures the radio's range under various conditions. He tests its resistance to moisture, dust, and temperature extremes. He analyzes its power consumption and battery life. He examines its resistance to jamming and interference. Every test reveals the same thing. This radio is better than anything Germany has. The range is extraordinary. In ideal conditions, 2 SCR 300s can maintain clear communication over distances exceeding 35 kilometers. Even in poor conditions, urban areas, forests, bad weather, they reliably work over 10 to 15 kilometers. The frequency modulation eliminates most interference. Vehicle engines, electrical equipment, atmospheric conditions, none of it significantly degrades the signal quality. The Germans' AM-based radios suffer constant static and interference. The SCR 300's audio is clear enough to understand every word. The battery life is 3 times what German portable radios achieve. The Americans are using modern dry cell batteries that hold their charge better and deliver power more efficiently. But it's the simplicity that really impresses Müller. He times how long it takes to train someone to use it. Schmidt, who has no radio operator training, is successfully transmitting and receiving within 30 minutes. Müller writes in his report, "The American SCR 300 represents a fundamental advance in tactical radio communication. Its combination of range, clarity, reliability, and ease of use is unprecedented. More significantly, its design prioritizes manufacturability, suggesting the Americans can produce these in large quantities." He pauses before writing the next sentence. "Germany possesses no equivalent system, nor can we develop one in the near term, given current resource constraints." It's April 1943 now. Müller submits his report to his superiors. It works its way up the chain of command. Some officers dismiss it. American equipment, they say, is flashy, but unreliable. The Americans don't have Germany's engineering expertise. But other officers, particularly those who fought in North Africa, read Müller's report with growing concern. They've seen the difference these radios make. They've watched American units coordinate with a speed and precision that German units can't match. General der Nachrichtenaufklärung Fritz Thiele reads the report in May 1943. Thiele is responsible for German communications intelligence. He understands the strategic implications immediately. He orders additional captured SCR 300s sent to Berlin for evaluation. By late summer 1943, German signals intelligence has examined more than a dozen captured units. Some from Tunisia, some from Sicily, one from a crashed American aircraft in Germany. Every evaluation confirms Müller's findings. The Americans have achieved a breakthrough in tactical communications, but it's the serial numbers that keep Thiele awake at night. In August 1943, Oberleutnant Müller compiles a supplementary report. This one focuses on something his superiors initially dismissed as trivial: the serial numbers stamped on captured SCR 300 units. The first unit, captured in February 1943 at Kasserine Pass, bears serial number 4721. The Americans have been in the war for 14 months at that point. Assuming production started in early 1942, Motorola is manufacturing roughly 300 units per month. Respectable but not alarming. But then more captured units arrive for examination. One from May 1943 in Tunisia, serial number 12,847. Another from July in Sicily, serial number 23,691. A third from August in Italy, serial number 31,334. Müller creates a chart. He plots serial numbers against capture dates. The trend line is nearly exponential. By August 1943, 18 months into the war, Motorola has produced more than 30,000 SCR 300 units. Production is accelerating. The company is adding factory capacity, training more workers, refining its assembly processes. Müller does the mathematics. At current production rates, Motorola will manufacture approximately 50,000 SCR 300s in 1943 alone. If production continues to scale, and there's no reason to think it won't, they could produce 100,000 or more in 1944. He compares this to German radio production. Germany's most advanced portable radio, the Torn FUB-1, is manufactured at a rate of perhaps 2,000 units per year. It's more complex to build, requires more specialized components, and needs trained technicians for assembly. The Americans are outproducing Germany in this single category by a factor of 25 to 1. Maybe more. But it's worse than that. Müller has been analyzing American force structure based on intelligence reports. A standard American infantry company, roughly 200 men, typically has 3 to 4 SCR 300 units. One with the company commander, one with each platoon leader. Sometimes more. By contrast, German infantry companies usually have one vehicle-mounted radio for the company commander, and no portable radios at all for platoon leaders. Company commanders communicate with their platoons using runners, physical messengers, carrying orders on foot or by motorcycle. The implications are staggering. An American company can coordinate all its elements in real time. A German company operates with communication delays measured in minutes or tens of minutes. Time lags that can mean the difference between success and catastrophe in fast-moving combat. Müller writes, "The Americans are not simply deploying superior radio technology, they are deploying it in quantities that enable a fundamentally different doctrine of tactical operations. Their infantry units at company and platoon level possess situational awareness and coordination capabilities that our forces cannot match." He includes another observation. Analysis of the SCR 300's design suggests it is optimized for assembly line manufacturing using semi-skilled labor. This is consistent with American industrial doctrine, which prioritizes quantity and standardization over artisan precision, while German engineering philosophy emphasizes quality and craftsmanship. The American approach appears better suited to the demands of total war production. It's a devastating conclusion from a German officer trained to believe in German technical superiority. General Thiele reads the report with mounting alarm. He understands what Müller is saying. America's industrial capacity isn't just larger than Germany's. It's structured differently. The Americans have built their entire manufacturing system around rapid mass production of standardized products. It's the same system that allows them to produce Liberty ships in weeks, B-24 bombers by the thousands, and yes, portable radios by the tens of thousands. Germany can't compete with that. Germany's industrial base is still largely structured around smaller workshops and skilled artisans. German manufacturing emphasizes quality and precision, which produces excellent equipment, but in much smaller quantities. Thiele forwards the report up the chain. It eventually reaches Albert Speer, the Minister of Armaments and War Production. Speer is one of the few Nazi officials who understands modern industrial methods. He's been working since 1942 to rationalize German war production, to move towards standardization and mass manufacturing. But he's fighting against decades of industrial tradition and a system riddled with competing authorities and bureaucratic fiefdoms. Speer reads Müller's report. He adds it to the growing pile of evidence suggesting Germany is losing the production war badly. But by late 1943, there's nothing to be done. Germany doesn't have the resources to develop a competing radio system. They don't have the manufacturing capacity to produce it in comparable quantities, even if they did develop it. And they certainly don't have the ability to retrofit their entire tactical communications doctrine around it. The Americans, meanwhile, are just getting started. To understand what the SCR 300 meant in practical terms, we need to follow it into combat. We need to see what it actually did for American units fighting in Europe. It's June 7th, 1944. D-Day +1. Second Lieutenant James McKinley leads a platoon from the 502nd Parachute Infantry Regiment, 101st Airborne Division. His unit dropped into Normandy 36 hours ago. They're scattered, disorganized, still trying to consolidate and link up with other American forces. McKinley carries an SCR 300. It weighs 35 pounds and it's awkward and he's already exhausted. But he guards it like it's made of gold. Because it is gold, it's the only thing keeping his platoon alive. He's in a hedgerow somewhere south of Sainte-Mère-Église. He's not entirely sure where. The drop scattered his company across 5 miles of countryside. His platoon, what's left of it, is pinned down by German machine gun fire from a stone farmhouse 200 yards ahead. In a previous war, or with a previous army, McKinley would send a runner back to company headquarters to request support. The runner might make it, might not. If he did make it, the message might or might not be understood correctly. Company might or might not have artillery support available. By the time any help arrived, if it arrived, the situation would have changed completely. Most likely, his men would die there in the hedgerow. Instead, McKinley keys the handset of his SCR 300. Redleg 6, this is Baker 2-1, over. 3 seconds later, He hears the voice of Captain Wilson, the artillery liaison officer with battalion headquarters 3 miles away. Baker 2-1, Redleg 6, go ahead, over. Redleg 6, request fire mission, enemy machine gun position, Stone Farmhouse. My location, plus 200 yards north. Grid coordinates. McKinley reads the coordinates off his map. Copy that, Baker 2-1. Shot out in 3 minutes. Stand by for adjustment. 3 minutes later, McKinley hears the whistle of incoming artillery. The first rounds land 50 yards beyond the farmhouse. Redleg 6, drop 5-0 and fire for effect. Copy. Dropping 5-0, fire for effect. The next salvo hits the farmhouse directly. The machine gun goes silent. McKinley's platoon moves forward. The entire exchange takes less than 5 minutes from first contact to resolution. No runners, no delays, no confusion. This same scene plays out hundreds of times a day across Normandy in the summer of 1944. American platoon leaders coordinate with their company commanders. Company commanders talk to battalion. Forward observers direct artillery fire with precision. Infantry units call in air support and actually get it, on target, when they need it. The Germans, fighting the same battles, operate differently. Their company commanders have radios, usually vehicle-mounted. Their platoon leaders have no radios at all. Communication flows up and down the chain of command through runners and motorcycle dispatch riders. It's not that German officers are incompetent or German soldiers are poorly trained. They're neither. But they're fighting with World War I communications in a World War II battle. By the time information reaches headquarters and decisions flow back down, the tactical situation has changed. Opportunities are missed. Threats aren't addressed in time. An American rifle company with 4 SCR 300s can operate as a coordinated unit across a front of several miles. A German rifle company with 1 vehicle-mounted radio at headquarters operates as 4 or 5 semi-independent platoons that can only loosely coordinate their actions. The difference is decisive. By August 1944, German after-action reports consistently note American communications superiority as a critical factor in American tactical success. One German regimental commander writes, "The Americans coordinate their infantry, artillery, and air support with a speed that makes counteraction nearly impossible. By the time we identify a developing attack and respond, they have already adjusted their approach based on our defensive measures." Another German officer observes, "American junior officers possess communications capabilities superior to our battalion commanders. This grants them an operational flexibility we cannot match. And it's not just in Europe. In the Pacific, Marine Corps and Army infantry units are using SCR 300s to coordinate in jungle terrain where visual communication is impossible and wire lines are impractical. On islands like Saipan, Iwo Jima, and Okinawa, American units maintain coherent operations in conditions that would fragment forces equipped with lesser communications. The Japanese, who have even more limited radio capabilities than the Germans, find themselves completely outmatched in coordination and fire support response times. By mid-1944, Motorola and other contractors are producing SCR 300s at a rate exceeding 10,000 units per month. American training doctrine has fully integrated them into standard infantry operations. Every infantry officer's school teaches radio procedure. Every infantry platoon trains with them constantly. The Germans watch this happen and understand they have No answer. In September 1944, Reichsmarshal Hermann Göring convenes a meeting of Luftwaffe technical officers in Berlin. The war is going badly. The Allies have broken out from Normandy. Paris has fallen. Soviet forces are approaching the German border from the east. Göring is desperate for technical solutions, wonder weapons, secret projects, anything that might turn the tide. Oberleutnant Heinrich Müller is among the officers presenting reports. He's been tracking American radio development for 18 months now. He has a thick file of intelligence reports, captured equipment analyses, and production estimates. Göring demands to know, can Germany develop a comparable system? Müller is direct. Yes, Germany could develop a comparable system. German engineers understand FM radio theory. They have the technical knowledge. But developing it would take time, at least 18 months, probably more. Building production capacity would take longer still, and Germany doesn't have the resources. The SCR 300 requires components and materials that are increasingly scarce in Germany. Copper for wire, rubber for insulation, certain rare earth elements for electronic components, high-quality batteries. Even if Germany could somehow manufacture comparable radios, they don't have the industrial capacity to produce them in relevant quantities. Motorola's Chicago factory employs thousands of workers and operates multiple shifts around the clock. Germany's radio manufacturing is distributed among dozens of smaller facilities, many of them damaged by Allied bombing. And there's a deeper problem. Germany would need to redesign its entire tactical communications doctrine. Officers would need retraining. Soldiers would need to learn new procedures. The organizational changes would be as significant as the technical ones. Göring, according to accounts of the meeting, erupts in fury. He accuses Müller of defeatism. He demands to know why German engineering cannot match American production. Müller, showing considerable courage, explains, Herr Reichsmarschall, the issue is not German engineering capability. The issue is industrial philosophy and resource availability. The Americans have structured their economy for total war production since 1942. They have functionally unlimited resources, a vast skilled and semi-skilled workforce, and modern factory infrastructure untouched by bombing. We have none of these advantages. The meeting ends badly. Göring dismisses the officers. No effort is made to develop a German equivalent of the SCR 300. There is, briefly, a stopgap attempt. In late 1944, German forces begin capturing American SCR 300s deliberately, when possible, for their own use. Some German officers carry captured American radios and use them to communicate with other units that have captured radios. It's a makeshift solution that highlights German desperation. There are even reports of German units monitoring American radio traffic using captured SCR 300s, trying to gain tactical intelligence. But American forces quickly learn to use simple code words and indirect references, minimizing the value of intercepts. By early 1945, as Germany collapses, captured SCR 300s are prized items among German units. An SCR 300 with working batteries is worth more than a machine gun to a German company commander trying to coordinate his decimated forces in the chaos of the war's final months. But it's too little, too late. The war is already lost. The communications advantage is just one of many technological and industrial advantages the Allies possess. But it's a significant one, and one that touches every infantry engagement. Every artillery mission, every coordinated attack. The Germans never closed the gap. The story of the SCR-300 is about more than just a radio. It's about the nature of industrial warfare in the 20th century. Germany entered World War II with what many historians consider the best trained, best led, and best equipped military in the world. German tanks were superior to most Allied tanks for much of the war. German aircraft were often more sophisticated. German optics, fire control systems, and mechanical engineering were world-class, but Germany lost the war. They lost it in large part because they couldn't match Allied production. The Allies, particularly the United States, didn't need to build better tanks. They built more tanks. They didn't need to build better aircraft. They built more aircraft. The same was true of radios. The SCR-300 wasn't necessarily better than anything Germany could theoretically engineer. But it was better than anything Germany actually fielded, and it was produced in quantities that gave American forces an overwhelming advantage in tactical communications. This reflects a fundamental difference in industrial philosophy. German manufacturing, even during the war, retained elements of craft production. Skilled workers assembling complex equipment to high tolerances. This produces excellent quality but limited quantity. American manufacturing, by contrast, had fully embraced Fordist mass production. Standardized components, assembly line techniques, semi-skilled workers trained to perform specific tasks rapidly. This produces enormous quantities of good enough quality. In peacetime, both approaches work. In total war, the American approach is vastly superior. The SCR-300 exemplifies this. Motorola didn't try to build the best possible radio. They built a radio that was good enough for infantry use, simple enough for rapid training, robust enough for field conditions, and above all, manufacturable in huge quantities. It worked. By the end of the war, more than 50,000 SCR-300s had been produced. American infantry units from Normandy to Okinawa operated with a level of tactical coordination that their opponents couldn't match. The Germans recognized this. Their intelligence reports from 1943 onward consistently identified American communications superiority as a critical factor in American tactical success. But recognizing the problem and solving it are different things. Germany, in 1943 and 1944, was already struggling with resource shortages, bombing damage to industrial infrastructure, and competing demands for production capacity. They couldn't afford to divert resources to develop and manufacture a new portable radio system, even if they'd had the technical capability. And so German infantry continued to fight with inadequate communications while American infantry coordinated seamlessly. That difference, multiplied across thousands of engagements over 2 years, helped decide the war. There's a broader lesson here about the nature of technological competition between nations. Technical sophistication matters less than production capacity and deployment. The best technology in a laboratory is worthless if it can't be manufactured at scale and fielded effectively. The Americans understood this intuitively. Their entire industrial mobilization was built around rapid mass production of standardized designs. The Liberty Ship program, the B-24 bomber production line at Willow Run, the Sherman tank plants, all followed the same philosophy. Good enough in huge quantities right now. The SCR-300 was another example of that philosophy, and it worked. The war ends in May 1945 in Europe, in August 1945 in the Pacific. The SCR-300, which changed tactical communications forever, continues in service. Oberleutnant Heinrich Müller, the German signals officer who first examined the captured SCR-300 in March 1943, survives the war. He's captured by American forces in April 1945 and spends 2 years in a POW camp. After his release, he works for West German telecommunications companies, helping rebuild Germany's civilian communications infrastructure. He never discusses his wartime work publicly, but colleagues report he held this enormous respect for American engineering and industrial methods. The SCR-300 itself becomes the ancestor of all modern military tactical radios. Its basic design, portable FM transceiver with preset channels and simple operation, remains the template for military communications for decades. The AN/PR C-77 radio used by American forces in Vietnam is a direct descendant of the SCR-300. So is the SINC GARS system used in the Gulf War. Even modern software-defined radios used by the US military today trace their lineage back to Motorola's design from 1941. The technology also crosses over to civilian use. After the war, Motorola adapts the SCR-300's technology for commercial applications. Police departments, fire departments, construction companies all start using portable FM radios based on military designs. The walkie-talkie becomes a ubiquitous tool of modern life. By the 1950s, you can buy a civilian walkie-talkie for your kids to play with. The technology that gave American infantry a decisive advantage in 1944 becomes a toy in 1955. That's how fast technical advantages erode when industrial capacity brings them to mass market. But in 1943, when German technicians first examined that captured radio in Berlin, none of that was foreseeable. What they saw, what terrified them, was simple. The Americans had solved a fundamental problem of modern warfare, and they'd solved it at a scale that Germany couldn't match. The Germans were right to be terrified. The SCR-300 didn't win the war by itself. No single technology did, but it was part of a larger pattern of American industrial and technological dominance that made Allied victory inevitable once American production fully mobilized. The German technicians tested captured American radio gear, and they realized why Americans never lost contact. It wasn't just because American radios were better. It was because American industry could produce better radios in overwhelming quantities, deploy them effectively throughout the force, and maintain that advantage year after year. That realization, that moment when the German officers understood the true scale of what they were facing, was one of many small turning points that collectively determined the war's outcome. Technology matters. Production capacity matters more. Deployment and doctrine matter most of all. The Americans got all three right with the SCR-300. The Germans never caught up. On March 14th, 1943, Oberleutnant Heinrich Müller sat in a Berlin laboratory and held the future in his hands. He didn't know it would become the standard for tactical communications for 70 years. He didn't know that children would play with civilian versions of it in the 1950s. He didn't know that his report would be studied by historians as an example of how technological intelligence can reveal strategic realities. What he knew was simpler and more immediate. Germany was losing the production war, and this radio proved it. 50,000 SCR-300s were built by 1945. Today, if you visit military museums in America or Europe, you can see examples of them in display cases. Olive drab metal, weathered by decades, silent now. They look like artifacts from another age. Simple, almost primitive compared to modern communications. But in their time, they were revolutionary. They changed how wars were fought. They proved that technological advantage at scale could be as decisive as any weapon system. And when German technicians tested them, they realized something profound. They weren't just examining a radio. They were examining the difference between a nation still tied to 19th century industrial methods and a nation that had fully embraced 20th century mass production. That difference decided World War II as surely as any battle. The SCR-300 sits in museums now, but its legacy is everywhere. Every time a soldier in a modern army uses a tactical radio, they're using a descendant of that olive drab backpack radio from 1941. Every time a police officer coordinates with dispatch, every time a construction foreman talks to his crew, every time a hiker carries an emergency radio into the backcountry, they're all using technology that traces back to Motorola's Chicago factory and the desperate need for infantry communications in 1942. The Germans understood radio theory as well as anyone. They had brilliant engineers. They had sophisticated manufacturing capabilities, but they were structured for precision and quality, not for quantity and speed. When total war required both, they couldn't adapt fast enough. America could. America did. And that made all the difference. The next time you see an old photograph of American soldiers in World War II, look for the soldier with the distinctive backpack antenna. That's the SCR-300. That's the radio that let platoons coordinate across miles of battlefield. That's the technology that German officers feared because they understood what it represented. It wasn't just about better communications. It was about a different kind of nation. One that could mobilize its entire industrial base, train thousands of workers, produce tens of thousands of complex devices, and deploy them effectively within months of entering the war. That's the real story of the SCR-300. Not just what it did, but what it revealed about the war's inevitable outcome. Thanks for watching. If you enjoyed this deep dive into World War II technology and its strategic implications, make sure to like and subscribe. We've got more stories about the hidden technologies that changed history coming soon. Drop a comment below if there's a particular piece of wartime technology you'd like us to cover. And remember, sometimes the most important innovations aren't the most glamorous. Sometimes a backpack radio matters more than a wonder weapon. Until next time.